Hello everyone. Once we have already studied the methods theoretically, okay? Now I've started this video with homogeneous linear ordinary differential equations with constant coefficients, okay? So I'll just give you the steps on how we'll solve these homogeneous linear ordinary differential equations. So with constant coefficients. So my first step is uh, you'll guess, okay? So I'll say guess y equal e raised to m of x. So that's my guess. So these are the steps on how to solve these homogeneous differential equation. So the second step is after you guessing, okay, get the first derivative of these and also get the second derivative, okay. So I'll say get the first derivative. So how will you get our first derivative? So this is an exponential function. So my first derivative, I'll write y prime to denote first derivative. Y prime equal, I'm differentiating y with respect to x, okay? So I'll say write e to the mx the way it is, e raised to mx, and then differentiate the power. So if you differentiate x, you'll get a constant term. So I'll multiply that by m. So my result will be m e raised to mx. Okay. So the third step, sorry, is get the second derivative. Okay. So after us getting the second derivative, we'll say y double prime should give me, again, I'll write now. So the second derivative, I'll get it from the first derivative. So I'll say m multiplied by e raised to mx the way it is. Then again, I'll multiply that by another m. So if I clear that bit, I'll get m squared e raised to mx. Okay. So once you have already solved for that, so our next method is our next step. Sorry, our next step is uh, we'll factor out. Okay, we'll factorize e to the mx. So we'll factorize okay, sorry for that. Once we have done that, okay, I'll try to explain these. Once you have already gotten your first derivative and second derivative, your second step is substitute these values, okay, the first derivative, second derivative, and the just the value of y time y term, okay, sorry. So just substitute these into the differential equation that has been given, and then factor out e to the mx, okay. So if you factor out e to the mx, you'll remain with a quadratic and auxiliary equation in that order of a quadratic equation, okay. So that's the fourth step. So the fourth step is let me check. So the fourth step is substitute back into the differential equation. Okay, substitute back to the differential equation. Okay, then after you have already substituted, the fifth step is now factorize. Okay, that's what we had already missed. So factorize e to the mx. So after you factorizing e to the mx, you will get an auxiliary, a quadratic auxiliary, okay, an auxiliary equation. So now once you have already gotten your auxiliary equation, okay, which is just a quadratic equation, let me just write this as a quadratic equation. So once having these, I'll tell you we have so many methods on solving quadratic equation. Okay, so we can use the quadratic formula itself. We can use completing squares method, and we can use that the methods of summation. Okay, so once you have solved for that, so I'll write the sixth step is solve. Okay, solve for the auxiliary equation. I'll give examples in my series of equation, in my series of videos, so don't worry much, just follow the steps. You can just memorize the steps. I will do this. So the seventh step, we are saying after you already solved for this auxiliary equation, okay, the second step is now get the roots. So you are solving by getting the roots. So we have three cases, okay. So we have cases. So I'll break step 7 into cases, okay. Step 7, we are saying solve for the following cases, okay. So I'll say case 1, okay. So I'll try to explain this. In case 1, we are saying once you already solve for this auxiliary equation, you'll get two roots, okay, because it's quadratic, you'll get two roots. If you get two roots, for example, okay, so example, you get two roots, for example, m1 and m2, okay. So these are the roots that you have gotten from your auxiliary equation. So if m1 is not equal to m2, okay, that's the condition. If m1 is not equal to m2, I'll say this is distinct. I'll say this is distinct or real root. Okay, so these are distinct or real roots. So once you've gotten your roots, compare, are they equal? If they are not, they are distinct or real roots. Another way to determine these is this is just for shortcut. So another way is to say if you calculate b squared minus 4ac, okay, and you get that value is greater than 0, these will go down to real or distinct roots, okay. So these will go down to real or distinct roots. So this is just an easier way to get that. So if you perform this operation, b squared from the quadratic equation, b squared minus 4ac, and you get that value is greater than 0, it will take you to real roots, okay. Now what will be the answer of that general second order differential equation if it has real roots, okay. So I'll say it has a solution. So the solution to that ordinary differential equation, second order ordinary differential equation, if it has real roots, I'll write my answer as y of x, okay, equal c1 e raised to mx m1x. Remember, it's m1 because we have two roots, plus c2 e raised to m2x. So that will be my answer if we get the roots to be distinct, okay. So that's case 1. And again, so we'll continue to case 2, okay. So let's continue to case 2. So that's case 1, keep in mind. So we'll go to case 2. In case 2, we are saying similar. We are saying if now example we get two roots, okay, and these two roots are equal to each other. So for example, after solving the auxiliary equation, we get m1 and m2, okay, and it happens that m1 is the same as m2, okay. So if m1 is the same as m2, these I'll name it repeated roots, okay, or either equal or either coincidental. So these will be repeated roots or equal, okay, or I'll slash that again to coincidental. Okay, sorry for that spelling. So it's coincidental. Let me check. Coincidental roots. Okay. Identical. Okay. Identical roots. So that's the name for that. So if I get my roots m1, m2, I'll get that as repeated roots or either equal or coincidental or identical roots. And a shortcut method to that, I'm saying if I compute b squared minus 4ac, okay, and I get this value is equal to 0, okay. So if I calculate that value and I get equal to 0, I'll say I'll have either coincidental real roots or uh, equal roots. Yeah, equal roots. So once I've gotten that, so once you have that distinct or either repeated roots, you will say what will be the solution to what will be the general solution to that differential equation. So the general solution to that differential equation, I'll say, so I'll just write solution. So the general solution will be y of x should equal c1 e raised to m1x plus c2, check here, I'm multiplying by x, okay? So c2x e raised to m2x. So that will be my answer for that, okay? So please keep that in mind because we'll be using all these. Let me just maybe give them a boundary to show more focus on this. So these are the things we'll be using. So make sure you keep them in mind. Maybe just a method, maybe just to engage is in second order differential equation, mostly we are dealing with formulas, okay? Mostly we're dealing with formulas. So I'll want you guys to maybe make sure you understand and conceptualize more formulas in your computations, okay? So from that, we'll see case 3. So what does case 3 say? Case 3 says if you compute the roots, okay? If you compute these roots and you get the roots, for example, now for these roots that you're getting either a complex root, for example. So I'll just write example. So if I compute and I get the root, for example, m1, I get it to be a plus ib, okay? And also I compute m2 and I'll get that as a minus ib, for example. So these are complex, okay? So what will I call these? So this case will be complex or imaginary roots. And how do we know that is either complex or imaginary? We can easily compute b squared minus 4ac should give me lesser than 0. Okay, so if I compute these, it will take you directly to either complex or imaginary roots. Now, once we have either complex or imaginary roots, how would we solve for that? Okay, so we'll solve for that by the first step is we'll say the general solution. Okay, so the general solution for that, I'll write. So sorry, I want to explain something also. We can either use alpha or beta. Okay, so we can use alpha or beta here. So, but for this case, let's just use alpha. Okay, so let's use alpha. So that will be m1 equal alpha plus I beta, okay, and m2 equal alpha plus minus, sorry, so this will be a minus at this point, minus I beta, okay. So once we have that, we'll say the general solution. So I'll say solution. So the solution to this differential equation is y of x, sorry, I keep writing g of x. So I'll say y of x should give me, okay, e raised to alpha x. Okay, sorry. Just for clarity, I want us to write these in a more cleaner and easier way, in a space that has a lot of space. So we're saying once we have gotten that, so we'll write e raised to alpha x into c1, okay, into c1 cosine of beta x, cosine of beta x, okay, plus c2 sine of also beta x. Let me just clean these a bit. So I'll write y of x should equal e raised to alpha x into c1 cosine of beta x, don't mind my beta, plus c2 sine of beta x. Okay, so that's my answer. So I also need you to memorize this formula. We'll be using it in more examples to come. Okay, so that's all for this video. So in this video, we are saying these are the only methods for solving auxiliary. Okay, we have the cases and the method and the steps. So that's how we'll do that. So my second the continuation of this video, we are saying we'll see at an example. Okay, so let's see it at another example that we can now solidify to this concept. So please like, share, and subscribe to my YouTube channel, and have a lovely day.